Okay, everyone, today we're looking at section 3.5. In 3.5, we're talking about finding the domain of a rational function. Remember, the domain of a rational function are the values that x can take on. When you're dealing with a rational function that has a denominator, the denominator cannot equal 0. Okay, so when it says what values are excluded from the domain, the values that are excluded are the values that make the denominator 0. Okay? So, you start out by setting the denominator equal to 0 and solving for x. So in this case, x cannot equal 3. In my math lab, it's going to ask for these answers in interval notation. So your answer is going to be everything from negative infinity to infinity except for these values. So this would be negative infinity to positive 3, and then it gets a parentheses because 3 is not included, and then union 3 to infinity, and you're done. Next one, set x squared minus 9 equal to 0. X squared minus 9 factors, because it's the difference of squares, into x plus 3, x minus 3. Let's get that out of there so that looks like a minus in there. Okay. Set each one equal to 0. So x plus 3 equals 0. Gives me x cannot equal negative 3. X minus 3 equals 0. Gives me x cannot equal 3. So you start with negative infinity still, and you go to your smallest value, okay? So my smaller value is negative 3, and then you go your smaller value to your bigger value until you get to your bigger value to positive infinity. Okay? The last one, when you set x squared plus 9 equal to 0, subtracting 9 from both sides, x squared is negative 9, and when you square root both sides, you get x cannot equal plus or minus 3i. But those are not real numbers. And the only thing we're excluding is real numbers. So for this one, because it's not a real number, you want everything from negative infinity to positive infinity. Okay? To find the vertical asymptotes, your vertical asymptotes actually occur where the denominator equals 0. Okay? So, in this one, x squared minus 9 is x plus 3 and x minus 3. So x plus 3 equals 0 gives us x equals negative 3. X minus 3 equals 0 gives us x equals 3, which is our two vertical asymptotes. Because x plus 3 and x minus 3 do not cancel with the denominator. Now on this next one, when I factor the denominator into x plus 3 and x minus 3, you can see that the x plus 3's will cancel because they're both the same. So my only denominator that could be a vertical asymptote is x equals 3. Anything that cancels is considered a whole. And you will be asked to identify those wholes in my math lab. If x squared plus 9 equals 0, so subtracting 9 from both sides and square rooting, again, not a real number, so there is no vertical asymptotes on this last problem. Okay, the next thing you're going to look at is the horizontal asymptotes. To find the horizontal asymptote, you compare the exponent of the highest degree at the top with the highest exponent on the bottom. If it's less than, y equals 0 is automatically your asymptote. If they're the same exponents, you take the coefficients and divide them. And if it's bigger on top, there is no horizontal asymptote. Okay? So, my degree on top equals 1. My degree on the bottom equals 2. 1 is less than 2, so according to my rules back here, my horizontal asymptote is automatically y equals 0. Okay? The degree up top is 2. The degree on the bottom equals 2. 2 equals 2, so my horizontal asymptote is I divide the coefficients of the squared terms. So y equals 2 is my horizontal asymptote. The last one, sorry about that, you have y equals, degree is 3 on top, and the bottom, it's 2. 3 is greater than 2, and because the top is bigger, there is no horizontal asymptote. Okay? When you're graphing these functions, the first thing you want to determine is there symmetry by plugging negative x in for x. Okay? And then you want to find the y-intercepts. You want to find the x-intercepts. You want to find the vertical asymptotes. You want to find the horizontal asymptotes. And then plot additional points if you need them. So, is there symmetry? If I replace negative x with x, what do I get? In place of x, I'm putting negative x. So I have negative 2x minus 1 and negative x minus 1. Okay, to determine symmetry, did every sign change? Okay, my 2x changed and my x changed, but my negative 1 here and here stayed the same. So because some changed and some didn't, there is no symmetry. Okay? 2, to find the y-intercept, you plug a 0 in place of x. and get your y-intercept. To find your x-intercept, you put a 0 in for y, and all you care about equaling 0 is the numerator. Okay? So I'm going to add 1 to both sides. Come up here. Divide by 2, and x is 1/2. Okay? Step 4, are there any vertical asymptotes? Okay? Denominator equal to 0. Okay? That's how you find those vertical asymptotes. Add 1 to both sides. Get your vertical asymptote. And 5, your horizontal asymptote. Degree on top is 1. Degree on bottom is 1. So that means I do y equals the coefficient over the coefficient, or y equals 2. Okay? So now to sketch the graph. I'm going to put in a new slide here. So the first thing I want to draw is my asymptotes. So at x equals 1 and y equals 2. So x equals 1. There's my vertical asymptote. Y equals 2. There's my horizontal asymptote. Okay? My y-intercept is 1. My x-intercept is 1/2. So my y-intercept is 1. And I'm going to put a darker, just so that you can see it better. My x-intercept is 1/2. Now in this case, I probably need to figure a point over here and maybe over here. So if I put a 2, if x equals 2, okay, then I have y equals 2x minus 1 over x minus 1. So I get 3. So at 2, so I can see that my graph is in the bottom left, approaching both sides, and the top right. Okay? Let's do another example. All right. Step 1. Symmetry. Oh, sorry about that. Open my PowerPoint back up. It's trying to open stuff from below. If I plug a negative x in there, what do I get? So on the top, when I square a negative x, I still get x squared, and the same thing on the bottom. So if I look at this, I can see that I have exactly the same thing as what I started for. Because it's the same, this is even, which means it's symmetric to the y-axis. Okay? Step 2, find your y-intercepts by plugging a 0 in place of x. So 3 times 0 squared over -4 gives me 0. Find your x-intercepts by setting the numerator equal to 0. Square root both sides. Okay, step 4. Find the vertical asymptotes. Denominator equal to 0. Factor it into 2 parentheses because it's the difference of squares. And set each factor equal to 0 and solve for x. So subtract 2 from both sides of the x plus 2 and add 2 to both sides of the x minus 2. Okay? To find your horizontal asymptotes, remember, we look at the degree on top, which is 2, and the degree on the bottom, which is 2, and we know that 2 equals 2. They're the same. So when they're the same, we do y equals the coefficient over the coefficient. Okay? Putting in another slide to graph this on. Okay. Let's take out these pieces we don't need. Okay, so my graph. Okay, what did we find first? First we want to graph the vertical and horizontal asymptotes. So at 2 and -2. My horizontal asymptote is at y equals 3. Okay, I know it's got symmetric to the y-axis. My y-intercept is 0, and my x-intercept is 0. So the only point I know is 0, 0. So therefore, I'm going to have to go over here to the side and do an XY table to find some points. So let's look over here at this side first, over at -3, -4. Okay? Let's write down the original function. That's my original function that I'm graphing. So I'm doing 3 times -3 squared over 3 -3 squared minus 4. So that gives me a 27 up top and a 5 on the bottom. Okay, what if I put a -4 in there? So -4 squared is 16, so that's a 48 on top. 16 minus 4 is 12, so that gives me 4. Okay, so at -3, I'm at 27 over 5, which is a little over 5. So at -3, I'm up here. At -4, I'm at 4. So I can see my graph is doing this. And over here at +3 and 4, because it's symmetric, if I go and make the same point. So at +3, I'm still going to get 27 over 5. And at +4, I'm still going to get 4. So what about like 1 and -1? So I can see what the graph is doing in this area in between those two lines. Okay? So if I put in a 1, I have 3 times 1 squared over 1 squared minus 4. So that gives me 3 over -3, which is -1. So at -1, because it's symmetric to the y-axis, I'm going to get the same thing. So at -1, I'm at -1. And at 1, I'm at -1. So I can now see my graph like that. Okay? I'm going to skip number 7 for now because we've done a couple of these. Okay? And look at number 8. How do you find the slant asymptote? The slant asymptote only occurs when your degree up top and your degree is bigger than your degree on the bottom. To find your slant asymptote, you use synthetic division or long division, whichever you prefer if the problem is set up correctly. I'm choosing to use synthetic division. So because the bottom is x minus 3, I can use synthetic division. So x would equal 3, which is my number outside. I won't make that quite so long. And then inside I have the coefficients 1, -4, and -5. Remember, your first number comes down, you multiply, add, multiply, add. When you're looking for your slant asymptote, you don't care about your denominator. So y equals x minus 1 is your slant asymptote for this problem. And that finishes the lecture for 3.5.